Good day everyone. For our week 7, our topic is real numbers. Real numbers. Real numbers comprise of any number that you can think or use in everyday life. So real numbers is composed of numbers you think or use during your daily lives. It is the compilation of all types of numbers. So these are all types of numbers. Next, each real number represents a unique number along the number line. On the real number line, a point corresponds for every real number and a real number corresponds for every point. All real numbers is unique and corresponds for every point on the number line. This is the Venn diagram of the real number system. As you can see, the blue one or the biggest part is the real numbers, wherein it is composed of rational, integers, whole, natural, and irrational numbers. When a number is a natural number, that number will also fall under whole number. Also, that number is integer, rational, and lastly, real numbers. When a number is irrational, it is also a real number because, as you notice, rational and irrational are real numbers. So based on the diagram, these are the subsets of real numbers. We have natural or the counting numbers. We have the whole numbers, integers, rational numbers, and irrational numbers. Natural or counting numbers. These are numbers that we use in counting. That is 1, 2, 3, 4, 5, 6, and so on. The three dots, called ellipses, indicate that the pattern continues indefinitely. This set is also called the set of positive whole numbers, and the set does not include 0. These are positive whole numbers without 0 because when we are counting, we always start at 1. Next, whole numbers. These are numbers consisting of the set counting numbers and 0. 0, 1, 2, 3, 4, 5, and so on. So the numbers extend indefinitely. So the whole numbers are 0 and the counting numbers. Next, integers. The set of natural numbers, commonly called the positive integers, their opposites, and 0. So when we talk about integers that include 0, we also have the positive integers, that is 1, 2, 3, and so on. Also, we have the negative integers, that is negative 1, negative 2, negative 3, and so on. So integers are 0, positive integers, and their opposite, which is the negative integers or negative numbers. Rational numbers. These are numbers that can be expressed as a quotient a over b of two integers, provided that b is not equal to 0, because when b is equal to 0, our answer is undefined. Example of these numbers: 2/3, we have also 4.35, we have 0, negative 8, 5 over 4, 5, and 1/6, square root of 36, and 14. As long as you can express the number as fraction or quotient of two integers, they are under rational numbers. Irrational numbers are numbers that cannot be expressed as a quotient of two integers. It includes the non-terminating and non-repeating decimals. The best example for this is the value of pi. Their exact values cannot be expressed as either terminating or repeating decimals. However, you can use a calculator to find their decimal approximation. Numbers whose roots cannot be extracted are the only irrational numbers. For example, pi is an irrational number which is approximately 3.1415926. Example is for irrational numbers is pi, or the value of pi, Also, we have 5.9, 5.1961, 52, 423, and so on. The square root of 5 is also an example of irrational number. So we have here real numbers, or under real numbers we have the rational numbers Q. Also under real numbers we have the irrational numbers. And the numbers under rational is the non-integer. And also we have the integers z. Under the integers we have the negative numbers. And also we have the positive numbers or whole numbers. Next, under whole numbers, we have 0 and the natural numbers. Also, this is called as the counting numbers. This is the set of real numbers. Rational and irrational numbers together are called real numbers. So, the combination of rational and irrational numbers is called real numbers. Real numbers can be arranged in increasing or decreasing order. It would be easy to do this by expressing first all the real numbers in the same form. When we say the same form, you can convert the given into fraction or decimal for you to arrange the given easily, increasing or decreasing order. Let us have the illustrative examples. Example number 1. Arrange the following real numbers in increasing order. When we say increasing, that is from lowest to highest. So given -4, 5.8, -1/2, square root of 50, 4 and 2/5, square root of 36. So our solution for this, express all the given real numbers in decimal form, will be helpful. So we have -4 is equal to -4.00, -1/2 is equivalent to -0.50, 4 and 2/5 is equivalent to 4.40, and we have 5.8 or 5.80. Square root of 50 is 7.07. This is the estimated value. Square root of 36 is equal to 6. So therefore, we can arrange the real numbers in increasing order as the lowest is -4, followed by -1/2, followed by +4 and 2/5, followed by 5.8. Next is square root of 36 and square root of 50. Let us have example number 2. Arrange the following real numbers in decreasing order. So when we say decreasing, that is from highest to lowest. So given 9/7, -4/3, -1.65, square root of 2, 0, and 3/2. Solution, convert 9/7 into decimal, that is 1.285, and so on. -4/3 is equal to -1.333. That this is a repeating decimal. Next is -1.65. Square root of 2 is 1.41. This is the estimated value. Then 0. And then 3/2 is equal to 1.50 or 1.5. Therefore, the list of real numbers in decreasing order is 3/2, or this is the highest, followed by square root of 2, followed by 9/7, 0, -4/3, and the last one is -1.65. Let us have illustrative example number 3 in real life situation. 4 students divide a pizza that they bought after class. Represent the part that could be received by each member using real number. Our answer for this is 1/4. Each member will receive one part of the whole pizza, which has been divided into 4, because in the problem we have 4 students that divide the pizza. Next, illustrative example number 4. In election for class officers, 11 students declared as winners. There were 60 students in the class. Represent the part of officers to the whole class using real number. So our answer for this is 11/60. Since 11 out of 60 students are the class officers. The given according to the problem is 11 students as winners. The total number of students is 60 in a class. So that is 11/60. There are many problems involving real numbers that can be solved using the model approach. The following steps are suggested in solving problems. So step 1, read and understand the problem. Next, draw a sketch to visualize the problem. Next, identify the operations that will be used. Next, answer the questions asked. Check the answer if they satisfy all the conditions given in the problem. So from step 1 to 5, just follow this step for you to solve the given problem easily. Illustrative example number 5. There are 60 students in a class. 3/5 of them are girls. How many girls are there? How many boys? So as you can see, we have 5 as the denominator, so you can draw a figure and then divide it by 5. So we have here 3/5, the dark side, and then the lighter side is 2/5 for the boys. So for the solution, just multiply 1/5 by 60, so that is equal to 12. So that 12 represent the 1/5 of the figure. So next, that is 3/5. So that is 3 multiplied by 12 is equal to 36. Therefore, there are 36 girls. For the boys, that is 2/5. So that is 2 multiplied by 12, that is 24. Therefore, there are 24 boys. The class consists of 36 girls and 24 boys. That is a total of 60 students. Don't forget to like, share, and subscribe to my channel. Thank you.